Welcome to module 15 of Database Management Systems in IIT Madras BSc online program. We have so far been discussing about intermediate level features of SQL after the introductory features. And in the last module, we have talked about transactions, integrity constraints, additional data types and authorization. In this module, I would like to take you to some of the other features which are you can say in some way for the initial design of or a lot of smaller applications. This may not be critical, but these are really powerful tools to extend the power of SQL to an enormous level, if I should say. So, I categorize them as the advanced features of SQL. And these include functions and procedures in SQL. Don't get surprised. I started by promising that SQL is a declarative language. It is, but it has extensions which are procedural. So, we will talk about that. And another very important feature of triggers. We will see what do they mean and what kind of performance do they entail. So, function and procedural constraints. So, one way that there are two basic ways these can play around. One is we talk about SQL as a query language, and we talk about any other general purpose programming language like C or Java or Python as a native language. Somehow this term has come. I do not really understand why should it be called native, but it is. So, what you have, there are two basic models in which this is done. One is you have a conglomerate of C programs, functions and variables and so on, and you can actually invoke them from SQL. So, you pass the data to the C function and the C function gives you the result back, which is a kind of this is we often say is a embedded or rather extensional programming using SQL. And SQL through the query processor continues to exclusively interact with the database. The other model is instead of having them independently, you have the SQL embedded as a part of the native language program code. So, it comes as a part of, say, you are writing a C function. In between that, there is a certain way to put SQL commands, SQL statements. So, that is more of a strongly embedded programming. Again, all the transactions with the database through the query processor will be done from the SQL, but here they are not kind of independent entities, but kind of C program will control the invocation of the SQL operations and collection of results and so on. Right. So, there are two different types, and what actually SQL over a period of time has done, that within SQL itself it has given function and procedural features. So, that even without using any native language, you can do a lot of procedural programming in SQL. This started in SQL 1999 version. I just mentioned when I talked about the history. But so, the function and procedures can be written in SQL itself, one option, or in an external programming language like the models we just saw, which could be C, Java, Python, anything. Functions written in external languages. So, why if we have a procedural extension, then why do we still want external programming language interface? The reason is the functions that are written in external language, which we were earlier calling native language, is particularly useful with specialized data types, images, geometric objects, implementation of complex algorithms. You want to really make a complex design which is object oriented. You may have functions and procedures in SQL, but it is very difficult to do a pure object oriented design of certain parts, which you can do in C++ or Java very easily. So, you can do that, and using this external programming technique, you can take advantage of that design as a part of your database operations. So, these are some of the interesting things. What has also been introduced is what is known as a table valued function, which means that a function in SQL can also return a table, right. Normally functions return just simple values, but they can in SQL the functions can also return tables. And as we will see, there are several constructs that are available. So, I will just walk through these after explaining the function and procedure. Then for the remaining constructs, which are very much like the imperative language constructs, that is C or Java constructs, I will just walk through with the structure, because detail, I mean, they are just little difference in the syntax, but their conceptualization, their logical model and control flow are very similar to the languages we know. Details you can always pick up from the manual. Okay. The first is to how to define functions. So, in SQL everything, any definition starts with create. So, create function, the name of the function and the parameter, right, which you define. This is name and type. So, this is not an attribute, this is a function parameter now. The return type is written separately by returns, mind the S here. So, you know that depth count will take a varchar 20 value and give you an integer, right. Then begin and end is the actual function body. This is local variable. You can define several of them through declare, name and the type, and then you have a pure SQL query. So, what is this query doing? Select count star into dcount. So, it will count the number of records which satisfy the instructor.dep name, that is the instructor.dep name, the dep name field of the instructor table is equal to the dep name, which is the parameter given here. Right. So, you are given some name, passed some name, say physics, then it will check if the instructor table in the dep name column, whichever tuple has physics, that will be counted. You are doing count star, so it gets one value and put that as dcount, and then you do a return on, you return dcount. Note the S is not there. So, when you declare the function and you want to provide the return type, it is returns, and when you actually return the value, it is just return, the S is not there. Okay. So, this is what the function is. So, the way you can use it is, suppose now you want to find out all departments which have the budget for all departments which has more than 12 instructor. So, department name budget, that is coming from the department table, which is fine. But how do you write the condition? You are using this dep count function. So, you use dep count here and you are passing this department name, which is obtained from the department dep name attribute of the department table as the parameter here. So, this function will count how many are there, give you that value through return dcount, and you will check whether it is greater than 12 or not. If it is greater than 12, it is true, you take that department name and the corresponding budget in your output, otherwise you discard. So, that is how very simply. So, just the catch point is, even the declaration structure I find is very similar to what we do in the imperative language, except for the syntax. But this gives you the basic way you can do data exchange between kind of a procedural variable to the select from where query structure of SQL, and also how can you make use of that computed value in the select from where structure. So, this is a data interchange between the declarative part of the language and the procedural part of the language. So, that is the basic thing to see, the rest of it is just matter of syntax. Conceptually you will understand. So, these all we have discussed. So, you can understand that basically function is a parameterized view. I mean, I could have created that view count star as to give me the value, but when I create the view, I have to specify what is the department name. That cannot be a variable, but here that can be a variable, that can be a parameter. So, this is a parameterized view and can be used for several other purposes as well. Table functions are functions that return a table, which is very simple to see. One is in returns you provide the total table specification with, you do not need to give constraints and all that, but just the names of attributes as well as their types. And in returns now you have the actual query that gives you a table which matches the table you have promised you will return. So, that entire table will get returned now. So, the way to use it is, since so instructor of, this is the table function, instructor of, if you pass the department name music, will give you a table. So, to make it clear to SQL that it is not a table by itself, but it is a table returned from a function, you say from table. This table is used here to mean that a table function has to be invoked and that will give a table, and that table will be used in the select query, right. So, that is the kind of structure we are talking of here. Now, naturally, as you have functions, you also have procedures which do not return anything, which does not have a return value, but it has any number of parameters, and the parameters could be in and out. You can have as many as in parameters, as many as out parameters and so on, but those are just parameters, there is no returns, and we are doing the same kind of thing here, and this is how the department name is coming in. And what we have done here is, you can see that this name, dep name, is qualified by the name of the procedure, which says this is the procedural variable, right, because it is a parameter directly coming in. And what you have gotten here is d count is the out parameter. Now, there is no separate return statement either, because there is nothing, no specific value to return. So, you are setting the output parameter as a part of your SQL query, and so when it reaches n, it automatically, the control automatically returns to the caller, and those out parameter value will be available. Right. So, you can declare a integer variable, and then you can use this procedure. The choice here is, you have to use the word call. Call tells that this is a procedure, because as a function it can occur as a part of an expression. So, as we said, from table, it was implicitly understandable that it is a function, but here when it is a procedure, it is not a part of a, it cannot be a part of an expression because it does not have a value. So, you do a call, pass the parameters. So, this is the in parameter, physics goes here, the count is computed and it comes out as d count, right. So, this is how, so you have functions as well as procedures. Interestingly, SQL procedures, functions and procedures can be overloaded, like in C++ or Java. That is, you can use the same function or procedure name as long as the parameters differ in number or in the type. Now, there are several typical procedural language constructs. I will just run through their what is available, but make sure that when you want to use it, you have to look up your manual, because this area function and procedure support of SQL is an area where many database systems are not following the standard. They are deviant. They support similar kind of constructs, but the name may be different, syntax may be different, and certainly certain parts of the semantics will be different. So, well, you have the first thing you have is naturally compound statement, which you have already seen, begin and end. Anything you put between begin and end is treated like a single statement, as it is done in case of say Pascal or in terms of curly braces in C, C++. You have a while loop, which is while Boolean expression do, and you have a sequence of statements. So, these are all SQL statements that you can put, and then end is marked with end while. Repeat similarly has, and so in while certainly you continue as long as the Boolean expression is true. So, it means that it may or may not execute even once. Repeat will necessarily execute for the first time, do a sequence of SQL statements until a Boolean expression is true. It will keep on repeating, and the physical end, I mean the little syntax difference with what we see in the common programming languages, repeat until is where it ends, but here you need a separate end repeat to say that the scope of repeat has ended. You have a for loop. So, for R as, so this is more like what you have in language like Python, not exactly in C. You have in C you have a very complex structure, but here you say for R as select budget from department. So, it is an SQL statement. So, you have got the budget. So, what you have got R as is a relation. So, you have got that relation. So, now you can do a procedural statement, which is an assignment, which is marked by set. So, you have declared a local variable n defaulted with 0. So, you are incrementing n by this budget. So, this will keep on going as long as there are records in this budget relation that has come as R. So, all those budgets will be get added. You have if then else, if Boolean, I mean these are if Boolean expression, then else if, and so on. Else if is optional, else is default. You can very easily see, and if you want some examples, you can look at the book, but I did not include because procedural part I am sure you all are very conversant with the particular different semantics of the procedural constructs. There are two types of case statement, one which is very similar to switch in C, which is case variable, and there you write switch, then you write case. Here you write case and then you write when. So, when a value. So, when the variable takes value 1, you do the first sequence of statements here, first sequence of statements here, and then you come to the end case. If the value is 2, you jump over this, you do not do this, you do this and then come to the end. So, that is exactly like the C switch. Right. But there is a variant of this which is interesting which is called searched case, which is you do a case, and in when you do not write a value, you write an expression equal to a value. So, this SQL expression can be almost anything. So, that expression will get evaluated, and the value of that, if it matches value 1, then the first case condition sequence of case statements will be done, and so on. So, this naturally, I mean whatever you can write in the simple case statement, you can write in the search case statement, but not the other way around. So, this is a very powerful one, somewhat different from what we know in the procedural languages. It does support exception. So, you can raise an exception by signal, and when you raise the exception must be defined with a handler. That is, when you raise the exception, it has to know where does the control go, what should be done. So, you can define your own, or there are some default handlers available For example, what we are showing here is a declaration of an exception out of classroom seat. So, you are allotting students to the classroom and you have exhausted all seats, so you cannot allot more students. So, the condition is the exit handler for this. So, exit handler is an handler which is already available in SQL, which does nothing but to terminate and exit this begin end, whatever action was being done here. And that is a handler for this exception. Okay. So, this is how you declare an exception and you then you associate a handler with it, and whenever, so there are different logic that you would be doing here. So, if you come across the situation where the exception condition has arose, for example, the class is full and still you are trying to add a student, then you will signal this exception, which will take you out of this, will terminate this and will take you to the handler. Handler being exit, it will not do anything further, but there could be other possible exceptions and handlers. I did not want to go into details of this, they are just additional features. Finally, you can have external language routines as we saw, and they are very relatively simple to deal with. This is again a create procedure, this part is nothing new. The body is different, that you are saying this is language C and the external name. So, since it is a C program, you have to say where does it exist. So, you have to give a path name. This is some arbitrary path name where that function can be found. So, the procedure and functions from external language also can be used in this manner. Right. I talked about the benefits, certainly is many operations become more expressive, more semantically clear, as well as maybe more efficient as well. But there are certainly risks because you are letting the control out of your hand. So, it is going into a different space outside of the database system. So, there are possibilities of accidental corruption or security risk and so on. So, the care and different security choices like sandboxing may have to be used. So, you try to use languages which are more safe, where it is not easy to break, like, so I am not sure whether you are familiar with safety of languages, what it is called, like C is considered extremely unsafe. Several, particularly the string functions in C, are very easy to break by buffer crushing, and you can get access to the other data. So, C now has a set of safe versions of the string functions. Java is relatively more safe because it does not give you direct access to the data. It always goes through the JVM and so on. So, there are different choices you can make, but the bottom line is if you are using external language routines, you will get efficiency, but you will may have to pay for through the lesser level of security. So, be careful and you will have to take care of those things. Okay. Now, let us move on to something very different, which is also critical for database design. These are called triggers. Triggers are particularly let me tell you the concern. The concern is a whole lot of things we are doing which are read the data. You can read the data, that may be good, bad, whatever, but it has no consequence on the database. But the moment you do modification to the data, you write, you do insert or you do update or you do delete, then you have to make sure that several things have to remain consistent. You have to maybe, if you delete something, you need to record somewhere. You need to know who has done this delete for later on traceback, for auditing subsequently and so on. Right. So, these are insert, delete, update, these are called events. So, when these events happen, we may want, not necessarily every time, but when these events happen, we may want that we would trigger an action. That could be changing some other data, that could be flagging a message, anything. So, triggers are often used to enforce data integrity via referential constraints, check constraints, to update other tables. Like if you have to have this cascade, you will need this kind of mechanism. So, to specify a trigger, we need to specify events. We need to specify when to fire the trigger. Is it before the execution of the event or after the execution of the event? And what is the action that has to be taken? So, there are two types, before trigger. So, that runs before an update or insert happens. So, for example, it may be that the user space uses certain format of the data and the database uses a different format of the data. So, the user is trying to update the data given in the format in which the user is using it. But before you can allow it to be updated, you need to convert it to the format in which the database is actually keeping that data. So, before trigger is a very good way of doing that. You get to know that, well, update is going to happen, take that value, transform it and then allow the update to happen. So, there could be several other reasons also. And there is a before delete triggers. This is specifically kept as a separate group because it runs before delete, because delete is the most dangerous because you are removing something. So, you may have to check values, raise an error, see if this deletion is possible or not. The second, so these are timing wise, this happens before the event. The others can happen after the event, which is which will be run after update, insert or delete, which can update other tables for referential integrity, which can check at data, which can convert some data into for their data integrity purposes. You can do non-database operations and so on. There are other types of triggers also, but not so widely used, so I am not talking about them. Now, triggers can be associated with either rows or with statements. So, if it is associated with a statement, SQL statement, then it applies to all rows of a particular statement result. If it is said on the row, then it applies to a specific row. So, if you do a statement level with a row level, if you execute a statement with a row level trigger which has 100 rows, then those trigger will happen 100 times. So, you will have to be careful in terms of doing that. And in writing the action, you can actually refer to the table before change and table after change by referencing old table or referencing new table. So, this is some example of a trigger, create trigger. Everything in SQL starts with create trigger, before update. So, you know the trigger name, you know the trigger timing, you know the trigger event. So, three things are known. So, what you are saying is referencing new row as n row. So, n row is the new row that is going to happen, right, with the update. And for each row, you are saying new row grade, that is the grade already available in the new row. If it is blank, make it null. If it is blank, make it null. And then you do the update. Otherwise, maybe that the update logic will not work properly. Right? And you have this as atomic because it has to happen or not happen. It cannot be halfway. There is another little bit more detailed example which I will leave for you to read while you work and figure out what it is doing. It is pretty simple, straightforward. It is trying to compute the total credit of a student based on pass or failure. Now, the question is how to use triggers. would you, because trigger is kind of is a point where you can do something. Now, there are certain situations and there has been lot of cases where triggers have been wrongly used or used at wrong places, causing severe damage particularly in terms of performance. So, some typical situations where triggers are good are logging changes in a history table. That is, you want to write down that this has happened, this has happened, this has happened, for things that are important to remember. Then auditing users and their actions. I said you can write down who has done it, so that later on that person can be questioned for having done what he or she has done. Adding additional values to the table, referential integrity, login, username, time of operation and so on. Simple validations, data sanity and so on. Right? So, these are some of the typical ways to use trigger, but you have to be careful to remember, and that is severely important, is when not to use trigger. Right? It is like the Lays, once you pop you can't stop. You open a packet of Lays, you can't have one and stop, you keep on. So, triggers are like that, once you start using them, developers have shown the propensity to keep on using more and more of triggers. So, on red I have tried to put some of the things you must not be doing, like that you should not have too many triggers, they should be used very judiciously. Trigger code should be simple, they must not be complex. They should not refer to crossover, cross-server databases, go across databases and so on. Triggers in turn should not call triggers, chain effect, lot of them. Recursive trigger normally is set off, so never set it on, that is trigger calling itself. Functions, stored procedure, views, these are expensive, do not have them in triggers. Iteration, avoid iteration in triggers and so on. So, the whole idea is make triggers smart, selective, short, but very effective, powerful weapon to maintain the consistency of your database. We plan to have a tutorial on triggers to give you some more details, walk through examples and so on, some case studies the team has prepared, and one of the tutorials will talk more about how to and how not to use triggers. So, that brings us to the end of our module. So, we have seen the functions and procedures in SQL and we have taken note of the triggers. Thank you very much for your attention and see you in the next module.